From a gold mine in deepest Siberia emerges unexpected treasure. The remains of a 40,000-year-old baby mammoth.
This is a very unusual find.
2 years later, its discovery launches a new chapter in mammoth science.
It's a whole new door. It's a whole new light onto the past that we never had before.
Paleontologists and geneticists join forces in a quest for ancient DNA.
What we want to know is who is present at this time.
And to learn the secrets of the baby's life and the reasons for its death. It's a paleo detective story that begins in the high Arctic
Fantastic!
Great.
and ends in a distant lab where scientists are cracking the mammoth's genetic code. It's a walk through the real ice age with the baby mammoth. It is summer in Yakutsk, the capital of Yakutia in eastern Siberia, where our baby mammoth story begins. Yakutia is famous worldwide for its natural treasures, raw diamonds and precious minerals, and now an unlikely survivor from the Ice Age. Less than 300 miles south of the Arctic Circle, Yakutsk is a land of extremes. In winter, one of the coldest cities on Earth. At the National Medical Center of Yakutia, a team of scientific investigators gathers to autopsy the baby's remains. It's July and almost 90 degrees outside, so they're moving the carcass as quickly as possible to keep it from defrosting. This mammoth calf is an exceptional find. Over the past 200 years, scientists have studied only 4 other well-preserved young animals pulled from the frozen earth, known as permafrost. Mammoth experts from across the globe have flown in for the autopsy. The first step before even touching the body is to determine its condition using a CT scan. Medical imaging expert Naoki Suzuki oversees the work. He's a specialist in the use of non-destructive techniques to literally look inside the mammoth at organs and tissues thousands of years old. The carcass is sealed in a thick plastic coat. It will help preserve a layer of cold air around the animal during the lab tests. Paleontologist Ross McPhee is one of the lead investigators. The CT scan will provide images of the baby's internal structure, which will show the team what merits further study during the autopsy.
It's been highly damaged. It's been crushed in the head. Right on the top of the head, one bone has been pushed over on the other side.
The damage they see on the scan reflects the strength of the bulldozer's blow.
We want to remove each damaged part to anatomical right position.
With today's data, Suzuki will create a 3D image of the baby's skull.
Since we finished the CAT scanning, our next job is to see what we can find out just by ordinary techniques, just looking it over anatomically.
A gold mine may seem a strange place to find extinct woolly mammoths, but across Siberia, miners moving the crumbling earth along streams and riverbanks have been responsible for many major finds. And it's here that our baby mammoth was discovered late in 2004. The autopsy will take place in an ice house on the outskirts of Yakutsk, an urban equivalent of the traditional ice cave Siberians use for cold storage. Inside, it's a chilly 14 below. Two other specialists will lend their expertise. Dan Fisher can read a mammoth's life history in its tusks. Tom Gilbert studies the ancient DNA of extinct animals. Now they're ready to roll up their sleeves and truly touch the past. The carcass is only partially intact, without front legs or hind quarters. But the men are thrilled by what they see, the ancient face of a baby mammoth. The head, with its severed trunk, is a rare find. They linger over the baby's eyes and ears.
It's very interesting.
It could still be there on the other side, it's just lost water. This is still beautiful.
There's skin with an underlying layer of mummified muscle. The coarse coat of hair is mostly gone now, but even the condition of the exposed skin provides clues that will help reconstruct the baby mammoth's life story.
We'd like to know what happened to it during its life. How did it live? What happened to it at the moment of its death? And in all of this, we're relying on the tools and kinds of investigations that in some cases we wouldn't have believed possible to do only 5 years ago.
Across town, a hotel room is the makeshift laboratory for Naoki Suzuki and his team. Working around the clock, they are creating computer models from the CT scan, forensic tools that will help the team examine the baby's teeth and bones without cutting into tissue.
You see the two eyeballs perfectly preserved here.
Meanwhile, Ross, Dan, and Russian mammoth expert Alexei Tikhonov check the body for probable cause of death.
So look at this thickness of fat, right?
Guy was prepared for a long winter.
Right? The animal probably didn't die because it just was abandoned, stranded on the tundra without enough food or something.
Right. How long do you think it would take to build up this amount of fat? This would be right over the whole summer kind of thing, or actually mostly mother's milk?
I think that with good, rich mother's milk, that this fat could be built up easily over the summer.
What age do you think it is?
We're still figuring that out, but it's probably on the order of 6 months, maybe a few more than that, but almost certainly less than a year. Probably born not necessarily right at the beginning of spring, but shortly after the sort of later to middle spring.
Make it to the winter, it's quite incredible watching Ross and Dan and Alexei just look at things that clearly to me are just pieces of mud and bits of string and start pointing out bits of the anatomy. I managed to get the eye all right, but apart from that, it was quite a new thing, and it's really it's quite a unique opportunity insofar as we get to see, such a mammoth that could potentially be so well preserved.
But taking geneticists like Tom out of the laboratory and into the field is giving these seasoned mammoth hunters a new forensic edge.
It would be great to know the sex on the basis of the genetics.
It would be
as
very
opposed
good.
to.
As you said, it's a pretty old mammoth, this one, so any information we can get from it will fit nicely into the information that's already existing, trying to help complete the idea of what was happening to the mammoth populations.
In this condition, it's still
Nice.
good.
Just put that in its container.
Yep.
They hope this ancient tissue contains well-preserved DNA.
Having seen the dried specimen we got here and having seen what it looks like and having spoken to the experts, Dan and Ross and Adam and Alexia, we're really starting to get a grip on what this thing could look like. I'm kind of imagining that we could have maybe this high, maybe a little bit bigger, maybe a kind of like a dark brown coat, maybe a little bit darker maybe, about 350 pounds, maybe like some nice ears, furry tail.
Well, let's be fair, I'm a DNA guy. So, Ross, what do you reckon of my mammoth? Just a DNA guess.
Well, it's looking pretty good. Yeah. But you know, this is just a 6-month animal. And maybe I'd shrink him down just a bit. The hair looks good. I can see the wool and the long fur, the guard hairs.
What about those ears?
The ears need to be just a bit smaller as well. You know, they're not like elephants that are around today. They're much smaller, close to the head.
And the trunk?
Is great.
Yeah.
Trunk is great. Look how it can move around. Everything in its environment is there for it to touch and feel and look at.
Yeah, give me a high five.
Dan and his student Adam Roundtree are trying to figure out how the baby died. They are examining every square inch of the carcass, but there are no signs of injuries inflicted by predators. An attacking lion would have bitten the face and neck, leaving puncture marks on the mammoth's head or trunk, but the baby escaped this fate. There's more to the story of this 40,000-year-old baby than meets the eye. Inside the mammoth, there are secrets encoded in its genes. At Canada's McMaster University, geneticist Henrik Poinar is about to test the baby mammoth sample just in from Siberia. If he finds enough well-preserved DNA, he may be able to determine the baby's sex. If the baby's DNA is unique, he'll also attempt to sequence its genome, perhaps the first genetic map of an extinct animal. The men wear hazmat suits, gloves, and masks to prevent any new contamination of the sample from human DNA or any other organisms.
This is a 40,000-year-old piece of muscle from the baby mammoth of the Siberian permafrost. It's samples like these, and this particular sample, that may allow us someday to recreate this extinct animal, the woolly mammoth.
Frozen tissue from Siberia has provided Hendrik with some excellent DNA. But this baby is extremely old. Its DNA may have degraded beyond the point of usefulness.
The sample is being frozen down to minus 140 degrees with liquid nitrogen, and what this allows is to be finely ground into a fine powder that allows us to extract the DNA.
Samples are screened to see which are unique and well enough preserved to use for full genome sequencing. No single specimen will reveal why the woolly mammoth vanished at the end of the Ice Age, but the knowledge gained from each new study will bring us closer to solving the mystery. Back at the ice house in Yakutsk, medical imaging researcher Naoki Suzuki is getting ready to share his work with Dan Fisher, the tusk expert. Suzuki projects images from the CT scan onto the baby's carcass. They reveal bone structure and tooth formation and wear, elements key to Dan's forensic work.
It's interesting just that the neck is intact, is there?
Yes, it's intact. So you see the molars.
Studying the molars might help Dan estimate how old the baby was when it died. But only the tusk, hidden inside the skull, can reveal its exact age, if he can get to it.
Oh, that's great. Well, maybe this is just the first part of the next tooth coming.
Oh, yes.
Right behind there, there's an opaque area just behind the.
Easy.
So here's the little tusk.
So we couldn't find the tusk in the cranium.
We knew there was at least one tusk there.
we thought maybe there was the milk tusk, the deciduous tusk as well. But looking at this, I don't think so.
There was no milk tusk, but the right facial cavity shows the beginning of a permanent woolly mammoth tusk, no longer than a little finger. This tiny tusk can tell Dan whether the calf was well nourished and how fast it was growing.
When an animal consumes something, it's basically what it eats that becomes part of its body. And so by analyzing the composition of mineralized tissues, such as are present in the tusk of the animal, we can say something about the nature of the animal's diet.
Tixie, an outpost at the edge of the Arctic Ocean. From here, Ross will deploy his team on a hunt for a different kind of ancient DNA. Samples that will reveal what the environment was like during the baby's time. The only way to move around up here is by chopper, a 30-year-old Russian Mi-8. The team isn't looking for bodies like the baby mammoth. They're going after microscopic fragments of mammoth DNA suspended in the frozen soil. For tens of thousands of years during the last ice age, woolly mammoths thrived here on the roof of the world. Their extinction remains a mystery. Chasing mammoth DNA is hard work. The team will spend long hours shoveling dirt in the freezing cold. Bernard Bouygues, a mammoth hunter with years of experience in Siberia, is guiding them to areas that may be promising. Ross is scouting along ocean and riverbank for a site with easy access to caches of dirt DNA. Cliffs or embankments seem ideal, but it's impossible to find just the right exposure from inside a helicopter. This site was covered by debris.
Let's get out of here. It's not going to work for us.
The fog is thick, the visibility terrible, and the pilot is forced to fly dangerously low on GPS. The team has only a few days to get the job done. And with helicopter time running several $1,000s an hour, they can't afford to lose any more time. Ross will try his luck further down the coast.
Because, look, I mean, it's already 3 o'clock.
On this vast stretch of tundra in eastern Siberia, mammoths and other now extinct animals would have thrived during the baby's time. Ross has been following the trail of the woolly mammoth for more than 10 years. He daydreams about life during the last ice age, a period that lasted 100,000 years and saw dramatic shifts in climate, from warm to glacial and back again. The baby mammoth lived during a period of moderate warming. As Ross imagines it, this is Siberia 40,000 years ago.
Okay, you know, this is real mammoth country. I can just imagine them coming through here in herds, nothing stopping them, knocking over trees, looking for good pasturage. It must have been a great thing to see. There were several times back in the so-called ice ages which were as warm or perhaps even a bit warmer than today. And in fact, the baby mammoth lived right at the end of one of those periods. So we can imagine the baby and the herd that the baby was part of coming down into this valley, crossing over the river, coming down into this area here. And here comes a couple right now. One seems to be a male with the big curved tusks coming off in front. The female looks maybe in her 20s. This is the sort of age that I would have expected for the mother of the infant, of the baby mammoth. They're heading toward me now, so I got to speak just a little softer because I don't want to be a problem. What a pair of beauties, huh? The real Ice Age right in front of us. You can see some of the features up close that distinguish these guys from modern elephants. It's not only the big woolly coat, it's just the size of the entire head and the face. It's massive. And the reason for that is because of the tusks. The tusks, especially in the male, are so enormous and so heavy that it needs a great deal of neck musculature just to support them.
For now, it's just a dream. But as science begins to break the codes locked in ancient DNA, a clearer picture of the baby's world may soon emerge. On the Siberian coastline, Ross McPhee and his genetics team are men on a mission. Armed with low-tech tools, they drill for ancient DNA, collecting samples that are beginning to paint a picture of the baby's environment.
Nice, good size.
The geneticists will sample only the untouched heart of this dirt core, the size of a pencil eraser.
We've just been at a really great Holocene site on the other side of the lake. We've been collecting DNA samples, and I'll show you one. Hey, you're back. All right, so this is one of our cores of frozen soil. We're going to take it to the lab and we're going to see what DNA is in there to try and work out what animals were around. It's the same time as our baby mammoth. So, we should get an idea of what the plants were, what the animals were at the same time. It's quite amazing, really, to think that just inside a bit of this soil, we can find out everything about the environment. Obviously, I don't know exactly what's in this one yet, but it'll probably be something like this.
Like their elephant cousins today, mammoths roam vast stretches of grasslands. Family bonds were strong. A calf this young wouldn't stray far from its mother. When our baby mammoth was born, woolly mammoths had adapted to the far north for several 100,000 years, living alongside deer, musk oxen, and creatures like the woolly rhino that have since gone extinct. For the baby, like all newborns, this was a world of discovery. A 6-month-old calf might mimic its elders, but would still lack the skills to feed itself. It would depend entirely on its mother's milk. At close to 400 pounds, our baby mammoth was still vulnerable, only just starting to learn about life. Back in Canada, tests continue on the baby mammoth's DNA. If results are good, Hendrik Poinar and colleagues will use it for sequencing, perhaps to create one of the world's first genetic roadmaps to an extinct animal.
So within every organism, every living organism in every body, you have a set of single letters, 4 letters in this alphabet called DNA, A, C, G, and T. These 4 letters in a certain sequence form genes, and these particular genes and complex organizations of these genes control what makes you, you, and me, me. And all the genes together actually create what we know and refer to as a genome.
In the sterile conditions of the clean room, they're preparing samples for the DNA run. They have to make sure that the baby's DNA is usable. Samples from animals this old often prove disappointing. Sometimes there's no DNA left at all. Sometimes the fragments are too damaged to yield any readable information about the baby's genes. Genes that determine everything from sex to hair color. DNA fit for sequencing would be a real prize.
Yeah, so for the molecular biologist, this is the best stage because at this point we have no idea whether or not the baby sample or any tissue sample actually contains DNA. So this is the sort of the moment of truth when we find out whether our sample actually has any DNA at all and whether we can go on and complete the genome or not. So this is a moment of truth for us.
To protect his eyes from the UV light, Hendrik wears a biosafety hood. Now crystal clear in the UV glow, will this genetic time capsule, 40,000 years old, help move mammoth science into the future?
Yep, it looks great. We got DNA. So actually, it turns out that we do have DNA in our sample, and so now we're going to go for the genome using the 454 machine. So it looks great. It's excellent. It's good news. Well, now maybe, yes. Tell me which is which. To an evolutionary geneticist, this is the greatest archaeological project that ever exists. Forget the tombs, forget the pharaohs. The most exciting archaeological project is in your chromosomes. And in the past, we've never been able to get that from the mammoth. We've never been able to get it from a Neanderthal. Now this simple little machine that we'll show you is actually gonna dig out these individual letters and reassemble them into the entire genome of an extinct organism for the first time. And from that, we'll be able to tell where the genome came from, who are actually the mammoths closer to, why did they possibly go extinct?
It takes a steady hand to fill 2 glass plates with emulsified DNA for a run on the genomic sequencer. Cutting-edge technology that's changing the world of ancient DNA analysis. Each plate contains 300,000 tiny wells that produce flashes of light as each base is added in sequence. It will take 3 billion genetic base pairs to map the entire woolly mammoth genome. The machine reads millions of DNA sequences in a matter of minutes. Work it would otherwise take Henrik's entire lab years to accomplish.
Yeah, predominantly, probably 50% if we're lucky, but should be good. Okay, excellent.
We'll never get rid of those bacterial DNA in it anyway.
No.
We'll soon know the sex of our baby mammoth, a secret encoded in its ancient genes. In Siberia, the Mammoth expedition is racing against time and a wave of punishing storms. It's their last chance to sample DNA that will fuel their work on the baby mammoth's environment over the next year. Battling gusty winds, the chopper sets down only long enough to unload its cargo. Landing in the rain-soaked muck was a risky maneuver. Getting stuck out here would be a disaster. Working in such tough conditions is a fact of life on the tundra. The team is well prepared. And Ross knows the only certain thing about Siberia is how unpredictable it is.
I thought it was the best of all possible places, so you can imagine how awful the rest is. The reason is that right here we have a cliffside, and that makes it possible for us to drill. If you look anywhere else, there are just these very slight hills and swales. We can't find a place to drill. The seaside is going to be the best for us for this purpose.
Best, because cliffs are exposed and therefore accessible. It's relatively easy here to burrow a few feet into the permafrost and drill a sequence of cores covering a broad period of history. All of this work for tiny bits of soil infused with generations of Ice Age DNA.
So one of the big questions that people wonder about, including me, is how is this DNA getting into the soil? Like where's it coming from? Obviously, we haven't got a bit of mammoth inside that core. So it's a bit of an unknown question, but currently we think what's happening is that the DNA is basically coming from the urine or the feces of the animals. So if you imagine you've got your mammoth herd wandering around the plains here. Anyone who's seen a modern elephant knows that they urinate and defecate copiously. Urine and feces have got DNA in them. There's DNA from the intestines, DNA from the bladder is actually left in the urine and the feces. So what we've basically got is the mammoth is peeing on the ground, the urine is soaking into the ground, it will go maybe 5-10 centimeters down until it reaches the permafrost layer, and then it's just going to freeze. So we've basically got a frozen mammoth urine.
The team spends all day drilling, tedious but worth it. They already know that plants and animals were extremely diverse here during the baby's time.
Okay, your mat, pull out and keep it going.
Though it's only mid-August, it's freezing out here and the wind chill isn't helping.
Next. I wonder what's more fun, this or working in a gulag?
It's strange to think that invisible evidence like this might eventually help prove how, when, and why mammoths went extinct. For Ross, it's the reason to try this new approach to collecting.
It's fantastic because this means we can do paleontology without actually finding the usual kind of fossils, bones and teeth. Instead, we're looking for fragments of DNA, which, if they're long enough and discrete enough, the sequence will tell us what the animals are. And that's, for this kind of paleontology, what we're after. What we want to know is who is present at this time.
A few hours walk down the tundra. Dan Fisher and his student Adam hunt for mammoths from the baby's era the old-fashioned way, looking for teeth, tusks, and bones. Remains are everywhere, but without lab tests, no one can predict which contain good DNA.
So I'd say probably dealing with a young animal, no longer a calf, but teenager.
Okay.
Driver's license age, maybe.
A nice find, but not in the babies' league. Tumat is a small settlement on the tundra of northern Yakutia. Bernard Bouygues, the scientist's expedition guide, is also visiting sites that may have interesting mammoth fossils for scientific study. Every year, he checks out leads from local people who come across the frozen remains of ancient animals melting out of the permafrost. The tusks and bones Bernard and others collect are catalogued and studied in an ice cave laboratory in northern Siberia. Scientists depend on these new finds to advance their work, and our team will head there in a few days.
70 kilogram, 140 kilogram. When you have this in the mouth.
Everyone's having fun imagining the giant that once wore these tusks. But the most magnificent tusks Bernard has ever seen surely belong to the Jarkov mammoth. In 1999, in a first for mammoth science, Bernard raised its ancient remains, encased in a permafrost block, off the Siberian tundra and into history. Now, the spotlight of science future is on the baby mammoth and its 40,000-year-old genes. Mammoth country 40,000 years ago. For a 6 to 9 month old baby, it was an exciting and sometimes dangerous place. During the autopsy in Yakutsk, scientists speculated that the calf probably died in autumn, not from starvation, judging by its healthy layer of fat, but from causes still unknown. The baby has yet to learn that adventures can have consequences. A now extinct cave lion the size of a present-day African lion might startle a 5-ton adult. But an inexperienced baby mammoth would make easy prey for a 700-pound predator. This time the baby's safe, but there are other dangers out there. In the spring and summer, the shallowest layers of the permafrost melt, and the tundra feels like a waterlogged sponge under a carpet of vegetation. Things that look benign might become deadly traps.
I may go around a bit.
Okay. A baby mammoth crossing a little ford like this might very well be surprised and frustrated, might flail about a bit. If it was inexperienced, it could easily lose its bearings, roll over, become further stuck in the sediment. It may even be that the firm ground that's to be found deep enough would be out of reach of its short legs. A baby of this age would definitely depend 100% on his mother.
Dan thinks this is one of the ways our baby mammoth could have died. Evidence from inside the tusk will tell him more. Hatanga, Siberia in the high Arctic has become the mecca for scientists in search of ancient DNA. In 1999, Bernard Bouygues flew a 20-ton permafrost block containing the Jarkov mammoth's remains off the tundra. It would be the centerpiece of an ice cave laboratory he was creating in a hillside beneath the town. Over the years, he and other mammoth hunters have filled it with Ice Age fossils, turning it into the Arctic's premier mammoth museum. Today, it still houses the remains of the Jarkov mammoth and its breathtaking tusks. A slow melt of the block revealed that its remains were not intact. But what was there provided scientists with valuable information about the Jarkov and its environment. And the idea behind preserving deep frozen mammoth remains caught on. The cave now holds hundreds of fossilized remains, including many from the baby mammoth's time. At Henrik Poinar's request, Ross McPhee will sample more ancient DNA to help complete the mammoth's genome. The baby sample is extraordinary, but it will take a lot of genetic material to produce the results they hope for.
What we're looking for are the pieces that Hendrik has determined have a very high DNA content. And although in general the collection is well laid out, it's still a question of having to lift up the very heavy pieces, rotate them to try and find the number to see which is which. And we have a long way to go in a very cold ice cave.
2003. You don't know that one, yeah?
Meanwhile, Dan takes a break to sample tusks for ongoing studies. Like rings in a tree trunk, the layers of a mammoth's tusk record its life story. He'll work on the more fragile baby tusk with special tools at his lab in Michigan.
No, I'm down in the 400s now.
You want to study that one?
It's one that would be interesting. I think that'd be good.
We could.
Now.
Ross finds the specimen with huge DNA potential for Hendrik. Bone marrow at least 10,000 years old.
Okay, see, this is the real deal.
Yeah,
this is excellently preserved. Look at that. It's like you took a cow bone and cut it.
Yeah,
you can see exactly the same thing. There's no fresh blood. That's the only difference.
You need the bones for what? For what kind of soup or what kind of, what's the purpose? You have many guests. You want to cook kind of what we call French pot-au-feu, yeah?
Well, you know, back in the early days when more complete carcasses were being found, there were all these stories of the dogs smelling the carcass first and then starting to eat it.
Right.
And even in one case, I think the Berezovka mammoth, was it? The people actually cut off pieces and tried it. You know, I like what I do, but I don't think I like that much.
Not at that point, yeah?
Yeah, right.
Okay, let's try to cut that one.
It's amazing to think with samples so exquisitely preserved, accessing extinct genomes is now within our reach.
What works, works.
The marriage of paleontology and genetics seems to be paying off.
I thought we had further to go. Let's look at this beautiful piece. And the light-colored material in the center. So this is not unusual for Siberian fossils to have this kind of preservation. It's just that in this case, it is so beautifully preserved, it makes it worthwhile to try and get maybe intact cells out of it.
It's been 9 months since the baby's autopsy, and paleontologist Dan Fisher has just received the tiny mammoth tusk from Siberia. Hidden inside are clues that should give him a better idea of how the baby lived and died once it is sliced open.
Okay, it's time to carefully extract this little tusk and see what information it has in store for us. So are we good to go?
I think so.
All right. In a sense, it's like reading a book. We're going to see in the layers of the tusk really the story of this young animal's life.
Very carefully, Dan will cut the tiny tusk in half lengthwise.
About through.
Oh, there we go.
There we go.
It looks like there's a pretty well-defined line that leads up and sort of stops right at that color change.
Well, it could be a neonatal line.
You want to take a look?
Sure. Oh, goodness. I think that's it. Yes, I think that's a neonatal line.
A neonatal line is a structure inside the tusk that marks the time of birth. Patterns of change on either side of the line reveal the season the baby was born.
It's of course present just out at the tip of the tusk, and in adults it's already been broken or worn away. So it's only in the tusk of a baby that we could hope to see the signature of this moment preserved at the tip. You realize this is not just the first time we've seen this. This is the first time anybody's ever seen a neonatal line in any proboscidean.
Right. The first look at birth, huh?
Oh, yeah.
The team creates a 3D scan of the tiny tusk, a record of the discovery preserved for when the tusk is sent back to Yakutsk. A cross-section of the tusk, the shape of an apple slice and thinner than paper, is placed under the microscope. By counting the rings, Dan will learn the baby's exact age. Each ring in the ivory of the tusk represents a week of the baby's short life. Microsamples are milled from the tusk. From sample to sample, the compositions change, reflecting the changes in the baby's diet and showing whether it was healthy right before it died.
From this work, we've learned that our baby died when it was probably about 7 months old. It had a good life, even though it was a short one. At the time of its death, it was still well-nourished. It had fed well from its mother's milk and was even beginning to store its own fat for its first winter. And then the end came.
In Canada, Ross McPhee is delivering the mammoth samples from Siberia to Hendrik Poinar's genetics lab.
So, tell me what's going on with the baby.
Oh, with the baby, the results look quite fascinating, actually, quite interesting.
Yeah?
Yeah, no, I can't wait to describe in a little more detail for you.
What's interesting?
Early studies show the baby's 40,000-year-old DNA was amazingly intact. There's no doubt Hendrik will try to sequence it. Now he also knows the baby's sex, though he's prolonging the suspense.
What'd you bring me?
Well, now that you're really interested in extending what information you've got on the baby, this specimen might be the best we ever saw.
Okay.
That was just in beautiful condition.
Right.
So I thought, you know, what are the chances that it's going to be so intact that we can get really good genomic information from it?
Right, I've never seen anything completely intact, so. Wow. Holy cow, look at that.
So if you take a look at the structure here, you can see this is all marrow on the inside.
Right, right.
And, you know, in addition to DNA, you might even have intact cells.
A brave new world of ancient DNA.
Yeah, well, that's your job, my boy. Speaking of your job, what about the sex of the baby? Is anything turned up?
Yeah. Take a look at this. I'll show you. These are alignment sequences from the X and the Y chromosome. Take a look. See what you think.
Okay, so this shaded area is the baby, right?
That's right.
Okay, so I'm seeing here a T and a G, and what that would mean, I gather, is that this is probably a male because it's got both the T's and the G's.
That's absolutely correct.
So you got a baby boy.
So we have a boy.
Hey, we got a baby boy.
We got a boy.
Fantastic.
Isn't that great?
Wow.
Yeah, there you go.
40,000 years later.
40,000 years later, and we
what
know
the gender is.
it's sex. Yeah, I've heard good things about it.
No, it's very amusing.
Ross wants to see the machine that's advancing their work by churning out data at lightning speed.
That's fantastic. Good humor, though.
Yeah.
Genome sequencer.
Okay.
In the not-too-distant future, sequencing a species a day may actually be possible.
Now we've got the baby mammoth run.
How far are we into the run?
We're only a few minutes into the run, so it's actually just begun.
Okay.
But already you can start to see the individual wells sort of producing light.
Yep. So 6 months to completion.
6 months till we can actually complete the entire mammoth genome, that's right.
And then what?
Well, then we can start looking at, you know, this whole range of questions that we can begin to look at. I mean, there's the whole question about, with an extinct genome, is there an interest into recreating extinct hybrid organisms, right? In situ directed mutagenesis of Asian elephant genomes. And
That's mind-boggling. I mean, do you really think that's going to happen in our lifetime, sort of deal?
I think the implications, suggest that yes. I mean, that it will be discussed, and I think the possibility exists that it's not as far off as we think.
At the dawn of the 21st century, the prospect of recreating an extinct species was incredibly remote. Today, the question is not if, but when. Perhaps in the next 10 or 20 years, the day of the woolly mammoth will come again. For now, technology advances while we debate the ethics of our choices.
Wow. Well, I guess I'll see you in 10 years.
Looks like.
Hey, what you doing here?
Not quite sure. I think I'm just gonna turn it off. Hey!
40,000 years ago, a healthy 7-month-old baby male mammoth died a sudden death in Siberia. Unremarkable, but for the startling fact that he survived to tell his tale. Will science help him rise again? It seems anything is possible in the world of the baby mammoth.